Dr. Stephen Hicks from the University of Oxford is the joint winner of this year's Royal Society Brian Mercer Award for Innovation. He and his team have developed and tested smart glasses technology that allows people with impaired vision to navigate freely and confidently around the environment.
So what we're trying to do with the project is produce a pair of glasses that can enable someone who's got very little sight to allow them to walk around unfamiliar places, to recognise obstacles, and to get a greater independence than they normally have. What the user actually sees is a slightly reduced version of the world that we normally see. So rather than showing all the colours and textures and the great distances, we're really only showing the nearby things, so what we consider to be the most important stuff. So the person nearby, or the table nearby, or the bright wall. How we've done that is our cameras show only the distance to objects, and we turn that into brightness. So we're looking here at a prototype transparent display which we're designing to fit into our glasses. The image here is showing just nearby objects. So whatever is nearby becomes very bright, and when things move further and further away, they become darker. You can see my hands moving, you can understand that this is a person right here in front. And this allows you to have a more natural interaction with people nearby you. We've been working through a number of prototypes over the last couple of years, from a very chunky pair of ski goggles with this great range of LEDs, all the way to something which is starting to look like a normal pair of glasses. So our glasses have a number of different components to them. We have a small camera which is mounted into the frame, which detects nearby objects and feeds them back to the computer. We have the display that shows the overlay of the environment. Then we also have a small processor which is essentially the same kind of scale as a mobile phone. And it does all the processing work. So it works out where nearby objects are, it turns it into the right type of display for that particular person. Because remember, we can calibrate these for different levels of sight. And with this project, with the Brian Mercer Award, we're bringing in Phil Torr's work as a computer vision expert whose team developed complex algorithms to recognise objects in the environment.
So actually, I've been interested in whether or not there could be applications of computer vision in helping partially sighted for a long time. And then I saw on the internet Steve's project and thought this was incredibly exciting. I can see many scenarios where this sort of technology might be useful. One is in allowing people much more independence.
First of all, if you woke up in the morning, the room's still dark, these are perfect for detecting obstacles on the ground, things that might have changed. Once you get outside, our glasses can then help you interact with the outside world.
Because they can navigate the public transport system in a much better way.
One of Phil Torr's aims is to really allow this to capitalise on machine learning.
This would involve human annotators, taking images and outlining the object.
So say you've got your favourite coffee mug, or your particular pet, or areas around your environment that you're used to.
Machine learning involves trying to understand patterns and classify them into different types.
We expect this to be a system which learns with you and becomes more and more adept as time goes on.
Another useful use case is navigation of large public buildings such as this one. You might imagine a scenario in which the user says to the intelligent glasses, "Find me the exit." As the user gets closer to the door, the handle would be highlighted, allowing very easy access.
We're about halfway through the project of trialling out different types of cameras, different types of displays, and really looking at testing patients. So looking at which types of sight loss are most appropriate and how broadly we can define these so we can approach the largest number of people who really need help. We're really looking to produce a spin-out company to make these glasses, hopefully by the end of our next 12-month period. So where we're trying to go with this project is develop a regular pair of glasses that look quite normal, with transparent lenses that you can look through as you normally would expect. Many people still have a great deal of sight, so we want to be able to allow people to use their sight as they normally would, picking up different cues from the periphery or reading text in the centre. But what we'd like to do is add our information on top of that, so it extends it, so it makes it into an intuitive way of seeing your nearby surroundings in addition to what you're normally seeing.